Friends, right now we will be trying to identify the different types of elements in the periodic table in terms of the classification, in terms of metals, non-metals and metalloids. And we'll try to approximate how many number of elements will be present in the periodic table out of 118, which will be metals, and the number of elements which will be non-metals, and the number of elements which will be metalloids. Now let us look at the metals. Now, first of all, let us understand what is the meaning of metals, otherwise we won't be understanding anything here. Let us first see what is the meaning of metals and what is the meaning of non-metals. And after that, we will come to know what is the meaning of metalloids. First, let us look at what are metals. Metals, my dear friends, are those substances which have a tendency of giving out electrons. I know that you might be thinking, sir, metals are those substances which are shiny, which have metallic luster, which conduct heat and electricity. But again, right now I'm not talking in terms of physical properties. I'm talking in terms of their chemical properties, definition of metals. So how do we define metals in terms of chemical properties? So metals are those substances which have a tendency of giving out or donating one or more electrons. The more number of electrons which are donated by an atom of an element, we say that element will be that much of a stronger metal, which will have that will show that much of a stronger metallic characteristic, like say for example conduction of electricity. For example, in the case of aluminum, because it produces 3 electrons, that is, I mean to say, one aluminum atom produces 3 electrons when it undergoes oxidation process. Therefore, aluminum will be considered as a stronger electron because it produces more number of free electrons which are available for the conduction of heat and electricity inside the metal. Let us now look at the examples of metals. So if in case we consider, we continue with the example of aluminum, let us see how in the case of aluminum it becomes a metal. In the case of aluminum, my dear friends, what happens is that one aluminum atom, it gets converted into aluminum ion, and plus it liberates, it gives out 3 electrons. And that is how we have a situation wherein 3 electrons have been given out by one aluminum atom, forming one aluminum ion. So this will be a metal which has a tendency of giving away electrons. So let us try to identify the metals which are present in the periodic table. Now in this periodic table, my dear friends, we have a total of all the elements which are present in the first group of the periodic table are all alkali metals, which are the strongest type of metals, which give for the electrons the most easily give out electrons, and these are considered to be very strong metals which react very strongly with non-metals. So we have this first group of the periodic table completely made up of very strong metals, highly electropositive metals. Then the second group of the periodic table are also very strong metals, but their electropositivity is slightly less as compared to the electropositivity in the case of alkali metals. So here in the S block itself, there are total of 7 into 2, that is total number of elements as equal to 14. So if in case we consider metals, let us consider in the case of metals, we have total number of elements in S block as equal to 14, plus the total number of elements in D block, which the entire D block are metals, which are also called as transition metals or transition elements. Because they are a transition between the very highly electropositive elements on the left hand side and highly electronegative non-metals on the right hand side, because these elements which are present here are non-metals, like similar to chlorine, fluorine, bromine, the elements which belongs to the penultimate group, which is group number 17. Those are very highly electronegative non-metals. So we have those metals, those elements which are present between highly electropositive elements on the left hand side and highly electronegative elements on the right hand side. These metals, these substances will be called as the transition elements. Transition means the process when change is taking place. So here this is the process where change is taking place, and hence these are also called as transition elements. And because these elements down here in F block, they are present inside this transition element, hence they are called as inner transition elements, because they are present inside these transition elements. Because we know, my dear friends, that after lanthanum we get cerium here, and after actinium we get the starting of the F block series. So therefore, because these series are present inside the D block itself, they are incorporated inside D block. They start from inside the D block. and end inside the D block. Hence, these will be a part of transition series, and because they are present inside the D block, they will be basically called as inner transition elements. So here we have the entire D block elements. All of them are metals. So if in case we consider one series, it contains 10 elements. Then there are 4 series. It contains total of 40 elements. So therefore, in the case of D block, we have a total 40 elements which are present, which are metals. Again, the entire F block is basically metals. So all the elements in the F block, they have a tendency of giving out electrons, as do in the case of D block elements. So therefore, in the case of D block, as well as in the case of F block, as well as in the case of S block, on an entirety basis, all the elements which are present in these 3 blocks are all metals. So let's write down. Let us also include the elements which are present in in the F block. So therefore, here in F block, we have a total number of elements which is equal to 14 into 2, which is equal to 28 elements, right? Again, finally, in the case of P block, we know that the first element which is present here, that is aluminium, is basically a metal, right? Therefore, we can, on an average, see, we can go into specifics and we can talk about each and every element, whether it is a metal or it is a non-metal. However, right now we are not going to do that. We are going to find out just approximate values. So if in case we have got P block elements, in P block we have a total number of elements here, which is aluminum and the elements below it in group 13 of the periodic table. There we have total number of 6 elements which are present in the P block, which can be considered to be purely metals. So therefore, in the case of P block, we have got 6 elements. So if in case we make a total of that, we will be getting 14 plus 40 plus 28 plus 6. Let us do the total. So we know that 6 plus 14 is equal to 20. 20 plus 40 is equal to 60. 60 plus 28 will be equal to 88. So this is the point that I was trying to prove to you, my dear friends, that out of the total 118 elements in the periodic table, there will be 88 elements which are basically only metals. So there will be only 30 elements which is present in the periodic table, which will be either non-metals or they will be metalloids. So let's write it down. In the case of metals, we have total number of 88 elements. So the remaining non-metals and metalloids, both of them together will form only 30 elements. Now out of them, let us look at the metalloids. We know that carbon, then silicon below it. So these elements which are present here below it, which will be metalloids in general. We are not going into specifics. So if in case we consider metalloids, those will be around 6 to 8 elements in the periodic table. Let us consider 8 elements which are metalloids, which will be acting both as metals as well as non-metal, depending upon the situation, depending upon with whom it is reacting. If it is in case it is reacting with highly electropositive substance, then it will itself be acting as a non-metal. If in case it is reacting with a highly electronegative element, then it will itself be acting as an electropositive metal. So we now know that if in case we talk about metalloids, they will be around 6 to 8. Let us consider 8 metalloids which are present here. So if in case we have total 30 elements which are remaining, out of which 6 elements are metalloids, we have around 20 to 22 elements which are non-metals, which is present in the periodic table. So I hope so, my dear friends. Now you know how we have metals which start from the extreme left hand side, which go up till group 13 of the periodic table. Then we have group 14 of the periodic table, which will be primarily non-metals. Means it will be basically metalloids which will be present, which will have characteristic both of metals and the non-metals which are present on the right hand side of the metalloids. On the right hand side of the metalloids, like if in case we consider the third period, after aluminium we will be having silicon, which will be a metalloid. After silicon we will be having phosphorus, then sulfur, then we will be having chlorine. All these will be non-metals. We can consider these to be all these elements to be non-metals. However, there is one more category that we need to consider. We can't consider 22 remaining elements as non-metals. Why? Can you guess? It will be because of inert gases. Because inert gases don't react itself. They don't have any tendency. They can't have any tendency of acting like metals, right? They can't even act as non-metals, because non-metals as opposed to metals, will be having a tendency of accepting electrons. That's exactly what we are going to write it down. In the case of non-metals, we'll be having a situation wherein, as opposed to aluminum, they will be having a tendency of accepting electrons. Like in the case of chlorine, we know that the atomic number of chlorine is equal to 17, right? Right? This is the atomic number of chlorine is equal to 17. So therefore, in the case of chlorine, it requires one electron to complete its octet and hence form the inert electronic configuration of its nearest inert gas, which is argon, having atomic number 18. Hence, chlorine will be accepting one electron, and after accepting one electron, it will form Cl minus ion, which will be chloride ion. And this is how chlorine will be acting as non-metals. As we have already discussed, metalloids will have a tendency of both giving away electrons or accepting electrons depending upon with whom it is reacting. Now, in the case of the fourth category of substances which are present here, we can have the fourth category written down as inert gases, because they don't act as metal, as well as non-metals, as well as non-metalloids, as well as metalloids. So let's count the number of inert gases which are present in the periodic table. So in the periodic table, we have total number of inert gases which are present as equal to 7. So hence, out of 22, we can remove 7, right? So therefore, we have around 15 elements in the periodic table which are non-metals. We can have inert gases equal to 7. However, in the case of metals, we have considered 7 into 2 here. However, one among them will be a noble gas. So we need to subtract one out of them to be more accurate. So therefore, the number of metals now becomes equal to 87. So this is how we have total number of elements approximately 87, total number of non-metals approximately 15, total number of metalloids approximately 8, total number of inert gases exactly equal to 7. So this is how we have the distribution of total 118 elements into metals, non-metals, metalloids and inert gases. As you can see, this is quite interesting because we can now understand that a huge majority of the elements in the periodic table act as metals, wherein they give away electrons. Very tiny fraction of the metals in the periodic table which are lying on the extreme right hand side of the periodic table, they are non-metals, wherein they try to accept electrons. We have metalloids which have both these properties, and finally we have got inert gases which is only equal to 7. So metalloids as well as inert gases are present in much lesser quantity. Non-metals also is a very small minority as compared to that of metals. So I hope so, my dear friends, that you have understood the distribution of all the 118 elements in the periodic table in terms of metals, non-metals, metalloids and inert gases.